Aloha Algebra 1 students, this is Unit 6 scatter plots. This is our table of contents for Unit 6, and as you can see, there are only 3 lessons, 4 including the vocabulary, and so this is a very short mini unit. Here's a breakdown of Unit 6. We're going to start off with vocabulary today. We'll then work on scatter plots, line of best fit, linear regression. On that same day, we're also going to be doing the review for Unit 6 test. That's going to happen on the 12th. And on the 11th or the 10th, depending on if you're Tuesday or Wednesday, will depend on your notebook check. And then from there, the following week, we'll do a group project. And that's going to be on the 18th through the 20th. We're going to start off today with Unit 6 vocabulary. And you need a total of 5 different color highlighters and a pencil. So this is the graphic organizer for Unit 6 vocabulary. If you have your supplies, let's get started. If you need to gather it, please press pause. So our first word is scale break. Take one of your highlighters, highlight the word scale break, and here is the definition. A mark on the graph that shows a break in the scale of X or Y. So first off, here's the mark. It looks like an arrow pointing both up and down, kind of like a heartbeat, the symbol of a heartbeat. And it says that it shows a break in the scale. So when we're talking about the break in the scale of X and Y, we're talking about X-axis and Y-axis. The scale is how much it increases both ways, how much it increases on the X-axis and how much it increases on the Y-axis. So as we look at the X-axis, we can see that it starts at 0, goes to 1, 2, 3, 4, 5, 6, and so forth. And so we're increasing by an increment of 1 or by a scale of 1. So the X-axis is on a scale of 1. And there is no break in the scale. It increases by 1 every single time. But if you look on the Y-axis, it starts at 0. And the next line it gets to is 30,000. From 30,000, it then goes to 35,000, 35,000, 40,000, 40,000 to 45, 45 to 50, 50 to 55, and so forth, going all the way up to 75,000. Now, between 30,000 and 75,000, it increases by 5. But from 0 to 30, there is not an increase of 5. It's an increase of 30. So whenever we have a break between 0 and some number, and the increment or the scale is different than each other. So again, here we're increasing by 5,000 each time. And here it increases from 0 to 30,000. So this is the increase to 30,000. We have to show that there is a scale break, meaning between our x-axis or a 0 and the first line that it hits, it is going to be different than all the other increments increasing. Okay, our next color, pick it up or use your next highlighter color to highlight scatter plot. And scatter plot is a graph with scattered data. So as I'm looking at this graph here, all of these points are scattered data. So take your highlighter and let's just highlight all of these points here on the graph. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And these points on the graph are scattered out. They're not in a straight line. They're not exactly in a straight line. And that's why we call this a scatter plot, because it's points that have been plotted on a graph, but they're not in a straight line. They're scattered apart. Okay, with your pencil, we're going to talk about trends in data. So there's very specific things when we talk about trends in data. We're first going to talk about direction. And in this, we can see that this is a positive slope, and so the direction is going up. Okay. The next thing we're going to say is, what does the data look like? Here we can see that there's like a cluster of points here and another cluster of points here. So if we have clustering, we're actually going to say that there's clustering, or we can say there's two clusters of points. Other things that you might see is if all of the data is on one side of the graph, or if all the data is on another side of the graph. Sometimes there is no clustering. Sometimes it's equally proportioned all the way across, and so we would say no clustering. Another trend in data is, what does it look like? Are the points all over the place? Are there points that are out here and down here and away from the other data? We would call those outliers. So if we had a point up here or a point down here and a point that's not close to this line, we would call that an outlier. And any data that looks like it's very close to the line, we call this approximately linear, because just like this arrow here that we know for sure is linear, all the data gathers around this arrow. And so we'd say this is approximately linear data. Which takes us to our next word, which is approximately linear. Now we know that linear means straight line. So approximately linear means kind of a straight line. Okay, our next word is bivariate data. Bivariate means two variables. So bi, two, variate, variables, and data. And when we talk about two variables, we're talking about our x and our y data. When we have a scatter plot, we're always going to have bivariate data. And as you can see, our variable on the x-axis is years of employment. So this is how many years the person has worked at a job. And our y-axis variable is salary. And this tells us how much money they've made. So in the first year of working at this job called a salesperson at company Z, we know that this person is going to make about $35,000. When they get to the fifth year, they're going to make about $45,000. When they get to their 11th year, they'll make about $60,000. And so what a scatter plot does is it helps us to analyze data in the long run or over a period of time. And that data will come from two variables. Again, in this case, years of employment and salary. And the last thing is a line of best fit. So the line of best fit is the line that fits the data the best. And here, I've already drawn your line of best fit for you. It's this arrow. So take your fifth color, highlight LOBF. This is what we call an LOBF, line of best fit. And let's highlight that with the same color. And as you can see, our line of best fit is going to run through the center of the data and be closest to all the data, or hit the most amount of pieces of data as it is heading, as we know, in the positive direction. Okay. If you have any questions, please let me know. Have an awesome day.